Hi everyone. For today's lab, we're going to be doing the standard molar volume of a gas lab, which is part of our stoichiometry unit. And there's a background information on the handout with the list of purpose. There are some background knowledge questions that I'd like you to answer. And the list of materials, the safety guidelines, which I'll point out as we're talking about the procedure of this lab. And we'll also have at the end the data that you're going to be recording based on the observations that I'll point out as I'm conducting the lab demonstration. So first, let's just kind of point out we are dealing with a strong acid, hydrochloric acid, so it's crucial that we follow the safety guidelines when dealing with a strong acid, as we have discussed in lab safety at the beginning of the year. A few of the materials that we have here, it's hydrochloric, as I mentioned. I've already pre-measured it so we can get the process going faster, so 10 milliliters. We also have just our distilled water. We have our new unfamiliar equipment, lab equipment called an stoichiometer, a funnel. We're going to be needing our magnesium, which originally came in this bag. I did some pre-measurement. For today, we're going to be using 1.5 centimeter, and it turns out that for every centimeter of this magnesium ribbon, it weighs 0.023 grams. So to repeat that, for every 1 centimeter of this magnesium ribbon, it's 0.023 grams. For today, I know the direction stated 2 centimeters. What we found in the past, it's a little too much, so we're going to go with 1.5 centimeters. We also have, instead, a modification in the procedure. It was, as stated in the past, using a sink filled with water. So to lessen the amount of water that we're using, we're going to be, what we have set up here is a large graduated cylinder with water already in it. And there are certain temperatures and pressure that you'll need upon checking the weather. The air pressure in atmosphere here in Manhattan Beach today is 0.98 atm. So that's one of the data points that you're going to be needing. On the second page, there's a table there. It's for the barometric pressure. So that would be 0.98 atm. So you just need to record that directly on the data table. The room temperature is in Celsius, so you do have to do a conversion. It's 18.0 degrees Celsius based on the thermometer we have up here. And then the water temperature is 17.3 degrees Celsius. That water temperature is something that you're going to need to convert to vapor pressure. I will provide the scan, a PDF of this vapor pressure table. Based on the water temperature, you could determine the corresponding vapor pressure, which will be part of the calculation for the data analysis part. All right, so those are all our materials, and the way the procedure works is I'm going to add our 10 milliliters of hydrochloric and in our stoichiometer. And then I will add water up through the very top, slowly as possible, not to disrupt the hydrochloric at the bottom. And then I'll add our magnesium and our copper, or the magnesium is wrapped in copper wire. And part of the, something to consider is why are we using copper wire for this particular experiment. I'll set it inside and then cap that, turn the whole setup upside down into our water here in the graduated cylinder, the large graduated cylinder. And so with that, we'll give it some time for the experiment to go, and I'll point out some of the things there. All right, let's get started. So first I'm going to add our hydrochloric acid. This one, since the graduated cylinder is pretty easy to pour, I'm going to just pour that slowly. we want to be as precise as possible, so we really want to get all of our 10 milliliters of HCl in there. At the end of this lab, there will be an error analysis. So along the way, whatever I'm doing throughout the procedure, keep in mind things you observe that you think could be sources of error, right? In fact, there is a calculation at the end of a % error. All right, next step, I'm going to add water to this, up through the very top. This time, it would be easier with the funnel. So let me set up our funnel here. So I'm adding water till, and I have to remove the funnel now. The last few drops here we could just add directly. All right, so I have it, there's even a meniscus of water there. Now what I'm gonna do is, notice here is our magnesium. It's 1.5 centimeter. And I had it pre-measured already. So part of what you have to do is calculate, well, if it's 1.5 centimeter, how many grams is it? Given the ratio of for every centimeter, it's 0.023 grams. So do a quick calculation for that. I'm gonna submerge this here as far as I could get it through, bend our copper wire. So we have something that will create essentially like an anchor. I'm going to add a little bit more water because I had a bit of overflow that happened there, which is expected. And part of something that you want to kind of consider and discuss, why is it it's so important that we have water all the way to the very top. I'm going to cap this. I should note the rubber stopper we're using has a hole in it. It's another part of the procedure that you have to consider. Why is there a need for that? Okay. To recap, our setup is we have hydrochloric acid towards the bottom 10 milliliters. The rest is water. We have our magnesium that is held by a copper wire, and then a rubber stopper. What I'm going to do is take this whole thing, set it upside down, and I'm going to move it closer this way. All right, so here is our setup. 3, 2, 1, and I'm going to have it slightly tilted. Keep in mind the rubber stopper has a hole at the base of it. Might be hard to see based on where you, or from your point of view, because it's a video, but I can tell you that I can see almost the movement of the hydrochloric acid as it slowly migrates down the odiometer. So it's slowly moving down the odiometer. It's roughly around this point now. So there's a mixing of the water and the hydrochloric. It's slowly getting there. It's about this point, about 2/3 of the way now. And I'll let you know from my point of view once it finally reaches, and it's right around there. So at this stage, what I'll do is I'll move the camera so that way you can see it. But what I can see from my point of view is that there's a lot of bubbles forming around the magnesium. In fact, at the very base, I could see that there's so much of this gas formation. Part of the pre-lab involves you having to predict the chemical reaction that we expect to see in this. And all that gas is getting produced by this reaction is getting trapped in the odiometer. Now you'll notice at the very top, there is an empty space now. The gases are trapped at the very top of this odiometer. And the way it's designed is there's measurements that we could use So currently, this is set up where we stand at this point. It's about 2 milliliters of gas that's being created. So we'll let this keep going.